Okay, let's do some math for fun. Today, we will be looking at this integral right here. But the truth is, I have no idea how to approach this at all. Seriously. However, this is actually from the 2015 Cambridge entrance exam, and that's called the step 2, and this is their question number 6. And the truth is, this is the part 3 of question number 6. Whenever you are doing a step question, in fact, you are going to have an experience. It's just like you go to a French restaurant and you order a 6-course meal. You are going to enjoy it. So, let me show you the steps that we take so that we can actually solve this right here. This video is sponsored by Brilliant. Brilliant is a math and science website and app with a focus on problem solving. They have over 60 interactive courses in math, science, and computer science, and they are always adding more. Since you are watching this video, then I know that you like calculus. Check out their calculus fundamental courses because they will provide you with a solid understanding of the concepts rather than just showing you boring computations. All of their courses have storytelling and hands-on practice, so you'll really enjoy the learning process. I really like their courses because they challenge me to think, and often they provide a different point of view than what I already know. The best part is that they have something for everyone, regardless what your level is. You can get started with basic algebra or geometry, or advanced calculus, or even quantum computing. Better yet, use the link in the description, brilliant.org/blackpenredpen, because that way you can get a 20% off discount to the annual premium subscription. Thanks to Brilliant for sponsoring this video, and now enjoy the video. So, for the first course, for part 1, we're going to first show this identity, and then we will be using this identity to do this integral. So technically, we have to do 2 parts already, don't we? Alright, anyway, let's get to work. Starting from left-hand side, we have the secant square, so let's go ahead and write that down. And we have the 1 over 4 pi and then minus 1 over 2x, right? Well, we know secant is the same as 1 over cosine, so we can write this as 1 over cosine square. And then notice that here we have 1 over 4 and here we have 1 over 2. Let's factor out the 1 over 2. Because the reason is, well, we can use the half angle identity later on. So once we do that, here we will just have 1 over 2 pi and then minus x. Alright, very nice. Now, let me remind you guys the identity. When we have cosine square of 1 over 2 theta, this right here, it's nicely equal to 1 over 2 times 1 plus cosine of theta. So just like that. Well, in this case, the theta is this right here. So have a look. We have the 1 on the top over, well, the bottom is going to be this right here. So let's put this down in blue. First, we have the 1 over 2. And then we have the 1 plus cosine, the theta is that, right? Which is the 1 over 2 pi minus x, like so. Very nice. And you can see that we can fix things around. This right here is 1 over 2. We can put the 2 on the top. So this right here, we have the 2 on the top over 1 is still 1, plus is still the plus. Now here's the deal. This is pi over 2 minus x, which is just a complementary angle of x. And cosine of a complementary angle is just going to be sine. So all this right here is just nicely equal to sine of x. So with that being said, we are done for that, right? So this is not like a proof. I will just put down check mark. Anyway though, we'll be using that to do this integral. You can see that, well, we can just go from left to right, right? Because the truth is, to integrate this, not ideal, but we like to integrate secant square. Check this out. This is a 1, this is a 2, so we will have to divide both sides by 2. This right here, let me just write it down again. The integral of 1 over 1 plus sine x. This right here is actually just equal to, well, we have the 1 over 2, right? And then the integral, and we have that, which is the secant square of pi 1 over 4 pi minus 1 over 2x, like that. And then, of course, we have the dx. Very nice. Now, let's do a quick substitution, or if you would like, you can do a substitution, go ahead. By the way, I will just do a substitution right here real quick, where you use u being equal to 1 over 4 pi minus 1 over 2x. And then differentiate both sides, we get du equals negative 1 over 2 dx. So you can see that dx is equal to negative 2 du. Well, here we have negative 2 du. This and that will cancel, but we have the negative. So don't forget that. We have the negative right here. And the truth is, this is just the integral of secant squared u in the u world. So the answer for that will be just tangent of u, and u is that. So let's go ahead and put that down, which is 1 over 4 pi minus 1 over 2x. And that's it. So that's the integral for that. Pretty straightforward. Plus c. And of course, you can do this integral with other ways, but like when they tell you to do it this way, there's a reason. So anyway, we finished part 1. So we have like the little appetizer already. And now let's take a look at part 2. And now for part 2, we'll first prove this integral identity, and then we'll use this to do another integral. And yes, that integral requires the result from part 1. So enjoy the experience, as I told you already. Anyway though, we actually have a hint right here. The hint is that we are going to do a substitution that y equal to pi minus x. If you use u right here, nobody will get mad at you, don't worry. But I do want to speak about how they come up with this. Check this out. Usually when we have definite integrals identities like this, usually it's about the symmetry. And to do that, what we do is just go ahead and do this plus that, which is the pi in this case, and then minus the input, which is x. So that's how they come up with this substitution. Yeah, that's how you can come with a substitution on your own if the question didn't give you that. And again, usually that's the way to go for symmetry identities like this kind of things. Anyway, I'm going to switch to x and y, so we will have x equals pi minus y, and I will differentiate dx is equal to negative dy. Good. Now, I'm going to write down left hand side again. Look at the integral from 0 to pi. We have x times f of sine x dx. We will take this integral from the x world to the y world. Well, to do that, don't forget these numbers are in the x world. So when x is 0, put it here, we get y is equal to pi, right? We have to take them to the y world as well. When x is pi, y is equal to 0. When x is x, we have that, which is just pi minus y. And then f, and then the input is sine of x, and the x is that again. So let's write down pi minus y. And this is actually really nice. You'll see why. Lastly, dx is the same as negative dy, so we'll just write that down right here. Okay, so this is pretty good. Now let's make this even better. This is what I mean by symmetry, that kind of thing. When we have sine of pi minus y, the truth is this right here is nicely equal to sine of y. What? Why? Because first it's on my shirt, but let me explain this to you guys real quick. Remember, sine is the y value on the unit circle. So if you have a y value right here, well, you have the same y value right here. The angle, let's say this right here is theta. Then in that case, the angle from here to here is precisely pi minus theta. So that's why. So one of my quick little proofs about the trig identities. Anyway, so that takes care of that, which is really nice. And secondly is that we have this negative here, which allows us to change the limits of integration to the correct order, just like the left-hand side. And the last thing we want to mention is that whenever we are doing this kind of things, remember the y or the x or whatever, they are just what we call the dummy variables. On the left hand side, ideally speaking, this in the end will end out to be a number. Likewise, the right hand side will also end up to be a number because we are dealing with definite integrals, right? And the truth is, the dummy variable doesn't matter. So just kind of get used to that. If you haven't done this kind of things before, then I know it will be really confusing. And to make it less confusing, I'm going to write this down in blue so you can see the small change. But it's actually nothing changing at all. On the left hand side, I'm going to write down the integral going from 0 to pi, and then again x f of sine x dx. So here we have the dummy variable x. On the right hand side, yes, we have this in y, but we can change that back to x. That's the discussion that we had earlier, because y is just a dummy variable. All right, so change all the y's to x. And in the meantime, we will actually distribute, all right? And don't forget, we are going to switch the limit of integration. So first, I will do pi times that in the integral. Again, it will be from 0 to pi thanks to this negative here. And then we have pi times that. So it's pi times f of sine x. Why? Because we want to combine, you will see. And let me close this integral right here. All right. Next, we have minus x times that in the integral. So we have minus integral going from 0 to pi. And then we have y becomes x now. So it's x. And then we have the f of sine x and then dx. So from here, we end up with this right here. So you can see that this is so nice. Why? Because this and that are the same, but this is negative, that's positive. We can combine them by just add this on both sides. So have a look. Add this on both sides, we get 2 of this integral from 0 to pi x f of sine x dx, which is equal to the right hand side, which is that, but we have the constant pi, we can put that in the front. So we have pi times the integral from 0 to pi f of sine x dx. Lastly, we can just divide the 2 on both sides and we will end up with that. Very nice. So ladies and gentlemen, the integral from 0 to pi, if we have x times f of sine x dx, this right here is nicely equal to pi over 2 times the integral from 0 to pi of f of sine x dx. Whew. So good. All right, so yeah, box this, will maybe put a check mark because you know this is not a final big boss. The big boss is question number 3, so check mark it, yeah. But we're not done with part 2 because there's an integral for us to do. Keep this in mind, and now let's have a look. Now, to finish our part 2, and seriously, this is just that you go to a fancy restaurant, they'll tell you, now, to finish course 2, we are going to serve you with like, I don't know, maybe 1 pairing or like, I don't know. You guys tell me. But we're going to finish this integral for part 2. And you can see that the x is right here, so the remaining part is f of sine x. So this right here is the same as the integral from 0 to pi x times 1 over 1 plus sine x. And now, thanks to this identity, we know this is equal to pi over 2 times the integral going from 0 to pi of just f of sine x, which is just this portion. So we'll write down 1 over 1 plus sine x dx. Very nice. Well, to do this, of course, you can just integrate it, but we did that already for part 1, right? So here's the deal. We are going to write down pi over 2, and then let's put on the result from part 1, which is negative tangent of 1 over 4 pi minus 1 over 2x, like so. And then we're going to go from 0 to pi, like that. And of course, we can just now plug in the pi, plug in the 0, and then subtract, and everybody will be happy. So let's make that happen. Firstly, we will put on the negative pi over 2 all the way in the front, like this. And then I'm just going to put a pi in here. We will get tangent of 1 over 4 pi minus 1 over 2 pi. So that's the first part. And then I'm going to subtract, put a 0 in here. So we have tangent of 1 over 4 pi minus 1 over 2 times 0. Very nice. All right, now let's do this in our head. This is pi over 4 minus pi over 2, which is negative pi over 4. So this right here becomes negative 1. And this right here is just 0, so we have tangent of pi over 4. So this right here is actually just equal to 1. Negative 1 minus 1, which is negative 2, times negative pi over 2. Altogether, we just end up with pi. Oh my god, yes, it's that number again, isn't it? Okay, so that's part 2. Do you think that we have enough practice, enough preparation, enough tools for part 3? Well, we're going to do the question right now. Have a look. Now, ladies and gentlemen, this is the best part. Of the video. Yes, this integral right here that I mentioned in the beginning. But let's take a look right here. Does this look like anything that we have done so far? Maybe, huh? Because we still have the integral going from 0 to pi, and we still have the 1 plus sine x. But this is to the second power, and the numerator is way more complicated. Oh my goodness, what should we do? Remember, if you give me this integral out of nowhere, then I wouldn't know what to do with it. But we did do part 1 and part 2 already. So maybe there's some kind of connection to help us with this. And yes, there is some kind of connection to help us with this right here. This is seriously just like a 6-course meal at a French restaurant because everything is planned for you, all right? So take a look right here. Let's go back to part 2, where we did the identity, right? The integral going from 0 to pi, x times f of sine x, right? We did that. But this wouldn't be so helpful right now because here we have x to the third power and this is x to the second power, right? So what can we do with this then? No hint for this equation. So we have to really think. We did this for part 2. Well, this is x to the third power. What if we repeat the same process, but instead of x to the first power, well, let's put it as x to the third power to match that. Let's give it a try and see what happens. And let me tell you, this is the way to go. So have a look right here. Anyway, so we're just going to repeat this, but this time we're actually going to come up with the identity on our own. So this is the beauty of this part right here. So cool, isn't it? Alright, so we do the same thing. Again, we'll still use y. Y is equal to pi minus x, and then x is equal to pi minus y, and then dx is equal to negative dy. So you will see that this is the integral, and then just do all that, which is going to be pi, and then 0, and then this time though, we will have to work out pi minus y, and then to the third power, oh my god, and then f of sine of pi minus y, and then on the outside here we have the negative dy. Let's just go ahead and finish this. Well, I'm going to expand this right here for you guys real quick, where we will get pi to the third power minus 3 pi square y plus 3 pi y square minus y to the third power. Alright? And just like earlier, this guy is the same as sine of y. And thanks to this negative here, we can switch the limits of integration. And just like earlier, we will change all the y's back to x. I'm going to write down the left hand side again. Here we have the integral going from 0 to pi, x to the third power f of sine x, right? dx. This right here is equal to, let me just distribute this and then again write down everything in terms of x. Integral going from 0 to pi, again thanks to this negative here. So here we have pi to the third power, and then we will have f of sine x dx, and then next we have minus integral going from 0 to pi, and then 3 pi square x, and then f of sine x dx, and then continue this guy. So we will have to add integral going from 0 to pi, 3 pi x squared f of sine x dx, and lastly minus integral going from 0 to pi x to the third power f of sine x dx. And you know the deal. This and that are the same, but this is negative, that's positive. Maybe you can just move this to the other side, right? Yeah. But hey, look, we have 2x to the third power. So we definitely do that. But we also have what? Minus 3 pi x squared. This guy. Aha! So for this particular case, we are going to move both of them to the left hand side, and then we'll just have the right hand side right here. So have a look. when we move this to the left-hand side, we will have the integral going from 0 to pi, and then we'll just have 2x to the third power, and both of them have f of sine x, so I'm going to factor that out in a minute. And when we move this to the left-hand side, it will become minus 3 pi x squared. And then this right here also have the f of sine x, so we'll just factor that out right here. Okay, this guy, you guys, this right here, which is going to help us out with that. This guy is nicely equal to all that. So this is equal to the integral going from 0 to pi, all that stuff. So pi to the third power, and let me just put them together. We have the minus 3 pi squared x, and then times f of sine x dx. So this is the identity for this. Yeah. Anyway, now I'm going to just erase all this, and hopefully we're actually going to make some progress. Oh my god, this is just a lot of work, but it's quite enjoyable. If you go to a French restaurant, like a 6-course meal, you're going to spend like 2-3 hours, but you're going to love it, of course. Anyway, you better not spend 2-3 hours on just this question, though, because you have other questions to do. Anyway, as you can see, we have this part right here already. So that means f of sine x is just equal to 1 over 1 plus sine x squared. All right, so just keep that in mind. Okay, so this right here is equal to, we have the integral going from 0 to pi. And then I'm just going to write this down, which is, let me just put that down on the top, which is pi to the third power minus 3 pi squared times x, and then f of sine x is the same thing right here, so I will just divide it by 1 plus sine x squared. Okay. At least we don't have to deal with like x to the third power anymore, thanks to this identity, right? So far so good. I'm going to erase this right here as well. Okay. Now what? Have a look. Well, if you take a look right here, we have x, and then on the bottom, that's the function in terms of sine x. Yes, we can use the identity from part 2. So let's go ahead and just break down this integral. I'm going to write it down as, well, here we have pi over 3, and then we have the integral going from 0 to pi, and then we have that 1 over 1 plus sine x, and then to the second power, and let's close that. And then here we have the minus 3 pi squared, and have a look. This right here, over that, thanks to the identity from part 2, we can just write it as what? Pi over 2 times the integral going from 0 to pi of 1 over 1 plus sine x squared dx. And notice that this and that are the same, so we can just combine the constants first. This right here is 1, and this right here is negative 3 over 2, right? So you will get negative 1 over 2. So this right here will be negative 1 over 2, and then we have the pi to the third power, right? Very nice. And this right here is the integral going from 0 to pi. Yes, I know they squared this guy already, yes. So I'm actually going to look at this as 1 over 1 plus sine x, and then square dx. Yes, we just have to do more work for this, but it's not so bad. Have a look. This right here is equal to negative, let's just put it as pi to a third power over 2. And then we have the integral going from 0 to pi. And remember, 1 over 1 plus sine x is equal to what? Well, that's equal to 1 over 2 times secant square of 1 over 4 pi minus 1 over 2x, isn't it? Yes. And then we have to square that, and then of course we have the dx. Man, check this out. This right here is going to be 1 over 4, so put that in the front, so we have negative pi to a third power over 8. Yeah. And then we have to integrate from 0 to pi, and then this is secant to the fourth power. of that, which is 1 over 4 pi minus 1 over 2x dx. Alright, I'm just going to do a substitution, and then I will use identity, and then we'll finish everything in the u world. So here I'm going to use u. Then u equal to 1 over 4 pi minus 1 over 2x, and then do the usual business. You see du is equal to negative 1/2 dx, and dx is equal to negative 2 du. Now take this integral to the u world, and we'll finish over there. This is equal to negative pi to the third power over 8. Integral, we'll put the 0 in here, we get pi over 4, so let's go ahead and put that down. Put a pi in here. Pi over 4 minus pi over 2 is negative pi over 4. And then we have the secant to the fourth power, and the input is u. And then dx is equal to negative 2 du. So far, so good. And we can see that this and that reduce. And we are going to use this negative to help us to switch the limits of integration. But this is still negative, so keep that in mind. Okay, so let me write that down. We have negative pi to the third power over 4. And if you switch it, yes, we will have the integral going from negative pi over 4 to pi over 4, right? But because this right here is an even function, so we're actually going to start from 0 to pi over 4. And just have to make sure that we double the result, right? So it's easier on the computational end. And to integrate secant to the fourth power in the u world, we are going to break it down as secant square u times secant square u. But secant square u is the same as tangent square u plus 1. And here we can do another substitution. Let w equal to tangent u, but let's just do that in our head, right? So if you do all that, let's see. This is going to give us negative pi to the third power over 2. Alright, so far so good. And then remember, the w is equal to tangent, right? And the derivative tangent is precisely secant square. So when you integrate that, just focus on this. You will get tangent, and let's put the u back. So we have tangent to the third power u divided by 3. So I'll put down the 1/3 here. And then we add tangent u, right? Yeah, so if you integrate that, you will get that. Okay, and then we just have to go from 0 to pi over 4. Alright, and then, whew, almost done. Put the pi over 4. Well, good thing is that tangent of pi over 4 is 1. So the first number is going to be 1 over 3, and the second number is going to be 1. And when we put 0, well, just 0, so very nice. Okay, so what do we have? This right here is negative pi to the third power over 2 times, ladies and gentlemen, that is equal to 4 over 3. And ladies and gentlemen, this guy and that guy can reduce. And ladies and gentlemen, oh my goodness, the final answer for that is equal to negative 2 pi to the third power over 3. And you know what? Let me tell you this fun fact. If you enter that Wolfram Alpha can only give you a decimal answer. But we found it. This right here is the exact answer in terms of pi. Negative 2 pi to the third power over 3. Oh my god, I feel so full after the 6-course meal. Let me know what you guys think. Alright? So, what an experience, isn't it?